Hey guys, so I just wanted to record a quick video about how to use the CO2 probe in case I'm not around or in case you need to look up how to do something. So pretty much, yeah, so you can use a LabQuest Mini, so you can plug at max 3 probes into this, or you can just use a link where you're plugging in 1 probe. So I'm going to use the link because I'm just going to use one CO2 probe, but if you wanted, you could, if there were enough probes available, or if you wanted to come in um, during a free period, you could run three probes at once. So I'm going to demo the beans, and when you first hook up the CO2 probe, so you can see down in the corner, so it's telling you this CO2 probe is measuring, so this is parts per million, so of a million particles in the air, how many are CO2, and it's saying between 0 and 1. And so actually it takes a bit of time to set up. Sometimes they come on and they'll say like 50. The parts per million in just like the regular air is probably something like 400, 500, 700. Maybe if there's a ton of people in the room, it might be higher. So you're just gonna let it warm up for a second until it gets to something around 400. So we'll see if that, so yeah, 900 after a day of kids being in the room makes sense. So your beans, you're gonna want to take them out so they're soaking, and you probably want to count out, I think like 30 beans would make sense. I'm just going to sort of grab a handful here. And you want to, I don't know if you can see this or not, but you want to sort of dry them off because you don't want a lot of liquid on the beans. But then basically you just dump them in this container. So yeah, I'll put in enough. And then obviously you're going to count out because you're trying to control, like you're going to do the same thing, 6 times. So you want to control the number of beans, but you honestly might want to also take the mass of your beans so that if you get different values, it might turn out that 30 beans have different masses. So you might want to take the mass so that you can figure out a rate of cellular respiration per gram of bean or something. So just so you know, the CO2 sensor has 2 settings. And if we're talking about beans producing CO2, you probably want to use the lower setting. So this is anything up to 10,000. If you're using the CO2 probe to measure CO2 that's been expelled in somebody's breath, you would want to use the higher setting. So make sure that it's on the lower setting, 0 to 10,000. And then, actually, yeah, so I'll show you this afterwards. So then let's make sure, so this will sort of tell you, yeah, what was the concentration of CO2 in the bottle. And be prepared, the sensor isn't something that reacts automatically. So even if you look at what you're going to measure, you're not going to measure the concentration every millisecond or something. So what we can do is this little clock will tell you what you're going to measure. And so this is going to say we're going to select for 600 seconds. But if you say, oh, I want to measure for 3 minutes, and then that should be fine. So, wait, yeah, no. So let's do it on seconds. Because every 4 seconds to take a sample makes a lot more sense. So let's just say, let's just select for 300 seconds. And that should be, yeah, that should be good. And then as soon as you collect, so as soon as you press the start, it's going to start collecting your data. So then we should get a new reading every 4 seconds. And so as we suspected, the amount of CO2 is going up. But sometimes, especially if you have an O2 probe, it might not look like anything's happening. And you might have to press this A, which will auto scale your graph to something that makes sense. So we'd only selected for 20 seconds, but you can also put your cursor on here if I want to say, oh, what's happening, if I want to make that axis different, or if I want to pull this one down. So it just affects the way your graph looks, obviously not the data. And so you get the idea, right? So we've set it to collect for 300 seconds, so it's going to keep collecting. But you probably should have, and as we have, a straight line. Unless, if you're using the light probe, it could be that, a leaf in light would be producing more or less O2. I showed you guys that example the other day. But for this, if I say, look, there's a consistent rate. So I'm going to show you guys how to analyze this. So when you stop collection, the thing that I cannot stress enough is if you do store latest run, that will sort of save your run so that I could collect again. So let's say I set this up again. So I'm going to say, I'm going to start collecting another run on the same. And so now this probably has a concentration somewhere up here. But what I would suggest to do is, so each person probably will be collecting 6 data sets. It's easier for you if you collect them all in the same graph. So that first run, I'm going to say data set options, and I'm going to name that run 1. So maybe I'm going to call that, trial 1 in tap water, whatever your dependent variable is, like, what salt concentration, what temperature, whatever your independent variable is. So now whenever I analyze that, it will tell me that it's tap water. I don't have to remember, the red line's tap water, because the more, so label your data, right? So data set options, label your, and I might say, this latest one is trial 2 in tap water. And that should save that one. So I'm going to stop this one. And let's say that I want to find out what was the rate of cell respiration. So I'm going to try to find, and honestly, I'm just going to pick the whole period of my graph here. And there's tons of different things that you can do. So you can find, if your curve was changing. I think this sets, tangent line. But the one that you're probably going to want to use the most is the linear fit. So we said that the slope was our rate of cell respiration. And so we're going to find the equation for both of those lines. And the part that we care about is the slope. And so it will tell you, so for this one, it's interesting. So the rate did change. So at the beginning, it was 9.698 parts per million per second. So every second, we got 9.698 more parts per million of CO2. And then as it continued, so it's interesting, the rate actually increased, that now we have 13 parts per million per second. So then, I'm trying to think what else. Yeah, so obviously you want to save your file as, whatever, Bean Lab sample. Is there anything else I need to show you? Yeah, if there is, I'll just come back and add it. But that's kind of the main thing. And then, so when you're done, right now, this CO2 probe, you can see that it's measuring 4,000 parts per million. Ideally, I want to get the concentration back down to, where this trial started. So it would be good if they all started at around the same place. And the way that you can do that is just, take a piece of paper. It's probably not going to work great, but let me see. If you just take a piece of paper and sort of wave it over the sensor, that it should take sort of the normal room air, and it takes a while for this to reset. But that should go down to what we really started with in the very beginning was, what was it, like 900? So this should reset. But then also remember that right now there's a high concentration of CO2 in the bottle. And so if I'm going to test this again, right, so I take out these and I'm going to put in 30 more beans, I have to reset the bottle. So don't forget, in between trials, you're going to fill the bottle with water, and filling it with water is going to push out all the air. Then when you dump the water, the bottle will reset with the normal air in the classroom, not the, oh, actually, that's interesting. Yeah, so now we have a lower parts per million. So hopefully that makes sense, but obviously let me know if you have any questions. Okay.